Hello everyone. My name is Predator Okta Ramadhani, and today's video I will explain what is MIPS single cycle architecture. So, which is this topic also the central to understanding how uh, how modern processors execute instructions efficiently and forms a foundation in computer architecture studies. But before we dive deeper into this materials, let's talk about what is MIPS first. So, okay. So, MIPS stands for microprocessor without interlocked pipeline stages, which is this is the classic examples of RISC or reduced instruction set computer architecture designed by John L. Hennessy in the early 1981. The MIPS design is known for its simplicity, efficiency, and for being widely used in education to illustrate how exactly processors work at the fundamental level. After that, we will talk about the concept of single cycle. So, yeah, let's discuss about this. The single cycle concept means that every instruction, whether it's computation, memory access, or control flow, completes in just one clock cycle. Okay, that means fetch, decode, execute, memory access, and write back all happen uh, with a single fixed length cycle. This means this is easy to understand and implement, but as we will see, there is maybe some trade-offs. Okay, now let's talk about the pros and wait. Okay, the pros and cons. Okay, let's look at some of the strengths and weaknesses of this single cycle approach. So the first one is pros, and for pros we got two points over here: simplicity and also easy to learn and implement. For simplicity, the control logic is straightforward since every instruction goes through the same steps in one cycle, and easy to learn and implement. Good for educational purposes, of course. And let's take a look. Cons for the cons is we also go to points uh, inefficiency and also scalability. Inefficiency, okay, the clock cycle must be as long as the slowest instructions. This means faster instructions have to wait, reducing overall speed. And for the scalability, not ideal for some for more complex instructions. CPUs for more complex deep CPUs or instruction sets and not used in modern high performance processors. Wait. Let's talk about main data path components. Okay. Now let's have a look at the main components of the MIPS single cycle data path. Okay. First one, we have a PC or program counter holds the address of the next instruction, and instruction memory stores program instructions. Register file contains 32 general purpose registers for data storage, and ALU or arithmetic logic unit performs arithmetic and logic operations, and data memory used for load and store instructions, and control unit generates control signals to manage data flow. MUX or whatever multiplexers select between different data sources. All of this work together so that each instruction can be completed in just one clock cycle. Let's get into the next material. Okay, now let's talk about MIPS instruction format. Okay. MIPS uses three main types of 32-bit instruction formats such as R-type for register-to-register operations like add or sub, I-type for instructions with immediate values as well as load, store, and branch, and the last one is G-type for jump instructions, G for jump, and we can see the example, some examples in the slides already. So let's get into next topic. Wait. Okay, let's talk about instruction execution flow. Okay, every instruction in this architecture actually, I mean in the single cycle data path goes through these 5 steps, okay? All within one clock cycle. The first one, instruction fetch. The instruction is read from memory using the PC or program counter. Instruction decode and register fetch. The instructions is decoded and the required registers are read. And execution. The third one is executions step. Okay. The ALU or arithmetic logic unit performs the needed computation or address calculation. And next step is memory access. If necessary, the data will be read from or written to memory. And the last one is write back. The result is stored in the destination register. And for example, in an add instruction, the processor fetches the instruction, reads the two source registers, adds the values in the ALU, and writes the result back, all in only a single cycle. Okay, maybe that's all enough material for today. Okay, so thank you for watching this video, and that's an overview of the MIPS single cycle architecture. Its concept, benefits and drawback, main components, maybe like instruction formats, and how instructions are executed. Understanding this model is a great foundation, really great foundation for exploring more advanced CPU designs in the future. Maybe that's all from me. Thank you for your attention.